Hey everybody, it's Brian from SCI, and it's time to talk about the point of interconnection. In this presentation, we'll be looking at different options for interconnecting PV systems to the utility grid or another primary power source, following the rules laid out in the National Electrical Code. We'll look at supply side, load side, and second service connections and talk about when one or the other may be appropriate. We'll look at the maximum PV system capacity that can be interconnected given the specific equipment and size of an existing interconnection and service equipment. And we'll talk about code compliant methods for these different scenarios. This is going to require a dive into Article 705, Interconnected Electric Power Production Sources. So, much like other articles, including Article 690, 705 is laid out in a very similar way. It starts off with a scope and definitions of some key terms, talks about equipment approval, system installation, identification of power sources, because think about it, when we interconnect power sources, that means there's more than one, so we want to know what those are, and so that's going to be an important consideration. Supply side and load side connections have many rules, and we'll be going into those. Power control systems we'll touch on briefly, and then you'll see that there's a bunch of other requirements in Article 705 that we're not going to get to in this particular presentation because we're grouping them in this course with other lessons that they fit in better with. Disconnecting means is a perfect example. You'll see that many of the requirements are similar to those in Article 690 or other articles in the code for disconnecting means. And so we'll talk about those where appropriate. Of course, because we have these power sources connecting together, we're going to need to be able to isolate them and separate them from each other. So an important consideration, just not one we're getting into in this lesson. Circuit sizing and overcurrent protection, very similar. Ground fault protection, likewise, we'll talk about that elsewhere. And there's much more in Article 705 as well. Let's start off taking a look at the scope and talking about primary sources. So 705.1. This covers one or more electric power production sources. We'll look at the definition of that in a moment. Operating in parallel with a primary source. So at least two power sources interconnected. That's the basis of Article 705. What does it mean to be operating in parallel with? What that really means is that there is a single AC waveform present in the system. The primary source sets that and establishes that and is the main source of power. Other sources that are interconnected with it operate at the voltage and frequency set by the primary source and then push current or exchange current with the primary source. PV system pushes current out onto the utility grid, for instance. Loads take it. Right. And so depending on what's going on at a particular instance in time, power may be flowing one way or the other, but the voltage is fundamentally and the frequency fundamentally being set by that primary source. Now, often when we talk about primary sources, the first one that comes to mind for most people, and this is how we interconnect a lot of PV systems, is the utility grid. And you'll find that that assumption is often inherent in a lot of the sections we'll be looking at in the code. But it's not the case that it is the only possible primary source. There's a lot of other cases out there where we could interconnect multiple electric power sources. One example would be a microgrid. Maybe the microgrid is being formed, set, and primarily supplied by generators. But within that microgrid, we have PV systems connected to that AC waveform, operating in parallel with it, and interconnected. Thus, they would follow under the rules of Article 705. Another example could be an off-grid PV system. We've got a battery-based inverter. It creates the AC waveform. It's the primary power source, but we could have AC-coupled PV connected to it, tying in on the AC output side of that battery-based inverter, operating in parallel, pushing current to the battery-based inverter that then goes onto the loads or to charge the batteries, whatever may be the case. So the primary source fundamentally is setting that voltage waveform and frequency, and the interconnected power source is operating in parallel with it. So a couple definitions we want to just kind of have in our head in Article 100 and in Section 705.2, power production equipment. So this would be equipment that is supplied by any source other than a utility service up to the source disconnecting means. So the PV system up to the PV system disconnect, that would all be power production equipment. Then it is interconnected to the primary power source. Now, it can be a little confusing. This could be a lot of stuff. PV, generators, fuel cells, hydro, wind, a lot of different kinds of power production equipment. You know, it's also very easy to think about like a coal-fired power plant as power production equipment. That's not within the scope of the NEC, however, so we want to keep this definition in mind and not get tripped up when we see things like power production equipment used in 705, and make sure that we apply that to the PV system or whatever other interconnected system we're working on. Another definition we'll want to keep in mind would be the power source output circuit, 705.2. These are the conductors between the power production equipment, so that's our PV system, for instance, and the service or distribution equipment, which is fundamentally being supplied by the primary power source. So this really, both of these terms are easy ways to distinguish between the boundaries between these two interconnected systems. Right, up to the disconnecting means the output circuit up to there, and that cutoff point allows us to decide which article we need to go to find the rules for the various pieces of equipment that are either part of one system or the other. Okay, so point of interconnection, where it actually comes together, these two power sources, POI, you'll see it abbreviated as point of connection, POC, point of common coupling, POCC. There's probably some others out there that didn't make it onto the slide. You get the idea, I think. The point of interconnection between the two power sources. First off, let's take a look at a load side interconnection. So load side, why do we call it that? Well, let's take a look. We're really going to be basing this on its relationship to the main supply disconnect and overcurrent protection device. Okay, so that main supply disconnect and overcurrent protection device is in between the loads and the primary power source. So this is easy to think of as the electrical service panel on the side of your house. The utility is the primary source. There's your meter, and we've got a main breaker that acts as a disconnect and overcurrent protection device. Everything else down here, these are what? Branch circuits running to various loads in the house, probably. These are all on the load side of that main disconnect. Okay, and the point of interconnection, where our inverter here is backfeeding a breaker, is also, like all of these branch circuit breakers, on the load side. In order to look for rules for load side connections, we'll turn to 705.12. Now we can contrast this with what we would call a supply side connection. We've got that same AC service panel, same supply from the utility grid as our primary power source. And this time we are interconnecting between the meter and that main supply disconnect and overcurrent protection device. So unlike all the branch circuit breakers down there in the bottom of the panel, we're above that main breaker. So we are on the supply side of that main breaker. Thus, this becomes what we call a supply side connection. So very different in some ways that we'll talk about as we get into it here. But one thing you can imagine is, hey, well, there's not that main breaker protecting the inverter connection from the utility grid. And as we know, the utility grid is a tremendously large source of current. Usually we have that main breaker to protect us, and then we have branch circuit breakers to protect the smaller wires running to outlets and loads. Here we're connected really to the full output of the utility grid from wherever that transformer is, right? There's going to be a transformer here dropping down our voltage to the service voltage. It comes in through our meter, and normally this breaker restricts everything down here. We're connected above it on the supply side, so we have to keep that in mind, and there's going to be additional rules that we have to follow thus for supply side connections. And we'll find those in section 705.11. And we'll also refer back to the services article, Article 230, looking at 230.82.6, and some other sections in that article that specifically allow and put some requirements on supply side interconnections. So these are two possibilities. Here's a third one, where we have a separate consumption and production meter. Right? If you think about those supply side and load side connections, everything that we consume or produce and sell back to the grid is all flowing through one meter, right? So this would typically be what we would call a net metered setup. Well, in some cases, we may not want to or be allowed to do that sort of an interconnection, and so we may need to have separate consumption and production meters. Sometimes this is called a buy-all, sell-all system. You have one meter that tabulates everything that you're buying from the utility, and you have another meter that's tabulating everything that you are pushing out onto the grid from the interconnected power production source, such as a PV system. This sort of scenario with separate consumption and production meters is also used in instances where we have a feed-in tariff. A feed-in tariff where the rate that you are paid for electricity that's being put onto the grid is different than the rate at which you buy it. So one meter can't tabulate both because, well, if they're zeroing each other out, then, they're not at different rates. So that could be in two ways. It could be you're getting paid a premium, so you don't want it to be counted at the same rate as what you're buying electricity for. Or it may be that there's some negotiated rate different from the retail rate of electricity, higher or lower, and the interconnecting utility or primary power source requires a separate metering for that. So basically, it's not that complicated. Maybe I should have put the picture up on the screen earlier, but you see here we've got our primary power source coming in through a bi-meter into our AC service panel where all the branch circuit and loads are connected. Okay, just like the other system. Now, instead of connecting on the load side in the panel or on the supply side between the main breaker and that meter, we're putting in a second meter. Probably, but not necessarily, connected to the same utility supply conductors. But what it really is it's kind of like a whole nother service. We've got a whole nother meter dedicated to the PV system. So everything this thing is making is going out through this meter and being tabulated, and probably some of it's coming in and we're buying it right back. Some of it though is going out to the utility grid. Either way, power's flowing, it's being tabulated, either coming in or going out here. So this is a common scenario in some areas, not necessarily in others. It's also a common way that large-scale systems are interconnected sometimes, where they have a meter for, maybe hundreds of megawatts that are being produced, and they may have a separate service, essentially, for everything that they're buying to run loads on the site, potentially. So it all depends on how and where you're interconnected, what the regulations from the utility are. But here's a look at this done in sort of a residential scale. Okay, so we've got a dual meter socket here. We've got the primary power source supply coming in. We've got it splitting off and running to the loads through this meter. We're buying through there. And then you can see this other meter, which hasn't been installed yet, but eventually there'll be another meter here. Well, that's quite clearly connected to the PV system, and everything that is produced by the PV system is counted through this meter here. Now, thinking back to Article 230 services, 230.2A5 does allow an additional service for parallel power production systems. So we are allowed to do this expressly stated in that section of 230. All right, that was kind of a quick overview of the different ways that we can interconnect. Next up, we'll talk about backfeeding and continue diving much deeper into the point of interconnection. I'll catch you soon.